All right, so I guess, yeah, we're logged in. Good morning, good afternoon, and good evening, everyone, and welcome to our highly anticipated webinar on Regress Without Regret, Enhanced Visual Regression with Multi-modal Generative AI. I'm Harshit Paul, Director of Product Marketing at Lambda Test, and I'll be your host for this session. Today, we have with us Ahmed Khalifa, a renowned expert in the field of AI and visual regression testing. Ahmed is a leading authority on generative AI and its application in software testing. His work focuses on leveraging cutting edge technologies to enhance the accuracy and efficiency of visual regression testing. In today's session, Ahmed will walk us through the challenges and limitations of visual regression, how multimodal generative AI can transform visual regression processes, practical approaches, and tools for integrating these technologies into your overall testing strategy. But before we get started, let's quickly talk about a few housekeeping items. This session would be 30 to 45 minutes long. The webinar is going to be fully recorded. So in case you need to drop off midway, don't worry, you'll get the full recording of this session over your registered email address. You will also find the full recording of this session over the AirMeet platform, where you are tuning in and watching the session right now. And you will also find the full recording of the session over the Lambda Test YouTube channel. So in case you're not already subscribed to Lambda Test YouTube channel, by all means, go ahead and do that. If you have any questions while we are presenting, please use the Q&A feature on the right side, and you can drop your questions over there. Towards the end of the session, we will be having a dedicated Q&A round where we'll be presenting all of it. And having said that, Ahmed, thank you so much for joining us today. The floor is yours.
Thank you so much, Harshit. It's really amazing to be part of this conference. And let me first of all share my screen,
Sure.
just to make sure that everything's working. Okay.
Yeah, I see the screen is up. Perfect.
Okay, and you can see the
Full screen is also working perfectly
full
fine.
screen.
Take it
Okay,
away, Ahmed.
thank you so much. So, hello everyone. It's really interesting to be part of this conference. I know there is a lot of people from all over the world in different time zones. So if it's midnight I think in India, and it's early morning in PST zone, so it's very nice to see you all here in this session. And I hope that you enjoy in the next 45 minutes in this session, where I will walk you through how could we leverage generative AI, especially the multimodal and the visual capabilities of multimodal, in not only in visual regression, but also in different quality and the testing capabilities. So let me start, just quickly introduce myself in very short sentences. I am a test manager in Accenture, and I have more than 10 years of software and quality engineering. This is something I really like to do, and to explore new technologies, to understand what is the new trends, to try new things. And this fun fact about me is that I was very close to become a professional football player, but at the end I am becoming a software quality engineer. So if any one of you has a contract for me in a big football club, I will be happy to shift. So so this is quickly to know me and to know where I'm come from. And yeah, before we start and go into the topic, I think this is a very important acknowledge that I really would like to thank Lambda Test for and the organizers for hosting such event. It's really interesting to see all of this number of testers join online test conference, and as it's written in the Lambda Test page, that this is driven by community and for the community. So I think it's really important that everyone share his ideas, his knowledge, and this is something that's really appreciated also for the organizers. So I just wanted to thank everyone for hosting such conference. And the second thing is just a disclaimer that I will present multiple demos in this presentation, and it will be mainly in AI. So please, the main idea to present such demos is to show trends, to show what's coming, to learn new things, to know what's in the market, and it's not something that's suitable for production implementation. So, and even if you try to replicate it, it might work in different ways because generative AI is non-deterministic. So this is something important to know. And this will be outlined today for today. So I will try to divide the presentation to 4 areas where we see the evolution of visual testing, how it starts, and what is the current status of visual testing. And then we will see in different way what is generative AI and what is rise in generative AI, what is trends in generative AI. And then we will see how this generative AI could be leveraged in visual testing. And then we will conclude and see what we have learned from this session. So this is, I would like to start with 7 years ago or 6 years ago, when I moved to Germany, I joined the company where we developing a software application that is used to generate models, reality models, 3D models that are used in virtual rooms, that are used in advertising, and these models like these cars. So it's a very realistic cars, and if you look at it, it looks very realistic from materials, from colors, from different perspective. And this was the main product. And I was joined as a software automation engineer, and my role is to test these applications that are used to generate such models. And actually, as you might know, in testing, we have this nice testing pyramids where you have unit tests that developers need to do to test their code. And then we have the integration test to test the interfaces between the applications. And then you have the end-to-end test. We were doing all of these tests for this application, but you could imagine that all of these tests were done based on the logs that are coming as an output from this application. So if you do a functionality, how you would like to make sure that this functionality is working, you need to go to the logs and validate the logs, because we didn't have the ability to test this functionality is working in a visual way. And this was the first introduction for me for visual regression tests. Or now we have something generated as an image, and this image need to be tested. So if I, for example, if I designed my model that the material of the driving wheel is leather, I need to make sure that the material of this driving wheel is leather, not only going to the logs and see that it's leather, but also to see it, right? To see this this image and to assure that the material is leather. So this was the first introduction for me for visual tests. And starting from this, we thought, okay, visual test could save our day. And what we are going to do, we will take screenshots of this output image, like the cars that you have seen. We will store this image. This will be our reference images, right? And then when the application change, when we have a new version, what we are going to do, we will take another screenshots and just compare between both. If they are identical, we are happy. If they are differences, then the application failed, and we need to understand what is the problem. So it's a good idea. So we said, okay, let's implement it. Let's find a way to do this. So we knew in the market there is a lot of tools exist to do this visual testing, and one of these tools is Playwright. So this is just an example. That's Playwright. It's very simple, right? It's an open source tools supporting multiple browser, and what you need to do is just take a screenshot in a very simple code, and then do the comparison using these screenshots. So what we did this comparison tool, and we get the image. This one is a base image, and this one is a new image from the new application. And what we have done when we go into this comparison tool, we found that this is the results. As you can see, it's all red. So, and this is the fact that we realized that to get these images, we use a rendering engine, right, inside our application. And this rendering engine could change from version to version, and this could cause these changes in pixels, and it's very hard to do something like this. So every time you do the comparison, it will be like this. And even if these comparison tools have like noise threshold to say, okay, please ignore the noise, or please make sure that the noise if to catch high noise. But even if you change this threshold, you will still have a lot of problems and you will not be able to test. So it was really tough, really taking a lot of time from us, a lot of efforts, and we decided at the end, no, this will not work. And this is actually the first thing in the visual testing. It's about pixel to pixel comparison. And the main idea here, how this tools is working, it's just taking the main image, and this image is represented as pixel, and then compare it to another image and pixel to pixel. And this was something not usually works because it changes in the UI. Even if you change from one version of the browser or one version of the application, it's very common to have it changing in the pixels between the image due to different rendering engine. So this rendering really matters, and it's really cause problems. It doesn't cause problem, actually. It's the natural of this rendering engine, but you will not be able to test. You will not be able to use this pixel to pixel comparison. So we found that there is a lot of false positive results. And it's very hard to review these test results. So it didn't work. At the end, it didn't work. And what we have done, we did it like this. So instead of using any tools, we used the virtual reality tools like the HTC Vive, and then we entered this inside this images in a virtual reality mode and start to check that the output of this driving wheel is laser. So it was also needs a lot of experience from us to be able to test such applications. But at the end, we failed to use any automation to do this comparison. So this was my first introduction to visual testing. It didn't work at the beginning, but then I realized there other methods exist that really could help in this visual testing. And then this is a evaluation of web front-end design, right? Now we can see a lot of new applications are based on web front-end design, this dynamic web pages. You have different viewports. You need to test on tablets. You need to test on laptops. You need to test on smartphones. So you need to do all of this testing. And you have not only static websites, you have only dynamic websites. You have a lot of evolution in this web front-end design. And this caused also, due to this evolution, this caused a lot of bugs, more visual bugs, right? So you need to test, if you test now in Chrome and see the same image on any other browser, it could have differences. If you see your image in, for example, in your mobile screen and then switch to a tablet, you could see an image. And all of these visual bugs was really important to be tested. So it's not only the functional, but we need only to take care of all of these UI images. And then some of smart engineers decided, okay, at the end, all of these renderings that we are seeing in the browser is coming from the CSS files, right, and the HTML and the JavaScript. This is what together, this is form the DOM. And if we have this DOM, then we could compare the DOM between two different versions, for example. So, and this was an idea, okay, don't do pixel to pixel comparison, but rather let's do a DOM comparison. So if I have the DOM for this form, sign in, and okay, I will go and check the DOM. I know that this is a sign in login title, and then I have a sign in login button as here. And then I have this background color, right? And in the next version, if there's a change, I will be able to identify it because the DOM structure is changed. And this was the second thing after the pixel to pixel comparison, that you could do a DOM comparison. So it's a nice idea because you now don't rely on pixels, but you rely on DOM. But with experience, you figured out that this also will not work. Because actually, you could have similar DOM that generates different outputs, and you could have even different DOMs that generate similar output. And this is very tricky. For example, you could have a DOM file where the image is completely changed, but still the name of the image is the same. And if you just compare, the DOM will say, okay, we are the same because the name of the image is the same, but the actual image is different. And in this case, you will have a false positive. And this was some of the limitation of the DOM, right? So that even identical DOM could produce different images, and even different DOMs could produce the same images. So it was a good step in visual testing, but it really also was not the ideal one. Still, there is a lot of false positives that make it hard to consider. And then people think, okay, let's combine pixel and DOM together, and this could give us better results. It did, but still it's prone to false positive results because at the end, the pixel to pixel comparison is really a problem when you have a change in the rendering engine. So this is also was the second evaluation for visual testing. After pixel to pixel, we have the DOM-based visual testing, and then people think, okay, what's better? What could be used to make things much more stable, to reduce the false positive results, and to have something that really works in visual testing? So we have now visual AI. So people thought, okay, now we have AI, we have a lot of tools that are able to do visualization, same as, for example, self-driving cars, where you go and see all of these self-driving cars can detect the stop sign, can detect the crosswalk, can detect the pedestrians on the streets, right? So we could use this feature or this benefit in visual testing. So for example, this is a very small video to see that visual AI could be used also in identifying visual differences. So here, this is a lot of coffee packages. And the main idea here is that this visual AI go and they check, okay, if this is matching the specification, then it's okay. So ideally, visual AI could be used. But just remember that this visual AI introduced before even generative AI. So here we just let's differentiate between both. So this visual AI was a third evolution in visual testing, where people start to see, okay, if you are a manual tester, what will you do? You will go into the page and will check the colors, will check the elements, will check the spaces here, and then decide if this is different or not. And this is what visual AI do. It replicates the process of the human eye and the brain. So it's trying to analyze the elements or the page element by element, divided the pages element by element, and then compare it from different perspectives, from the size, from the content, from the color, and all of the things. And this makes things much more better, right? Because you don't rely on pixel, differences. You don't rely on DOM structure, but you really focused on the elements itself. And this means that you don't deal, for example, if you have a font, you don't deal it with as pixel, you deal with it as text. If you have an image, you don't also convert it to pixels, but you deal with this image as an image. And this was very important part to make this visual testing less to false positives, right? Because now you are dealing with elements in the page. So introduce this visual AI, and the visual AI mainly takes the baseline of your application and do an element classification. So it do like, okay, this is the button, this is the drop-down menu, this is lists and everything. And so it does this element classification, and then using the locators to do this differentiation, or to do this, to check these visual differences. So this makes visual AI very good in terms of results. And it's now a lot of tools actually providing this visual AI. You could see a lot of tools in the market, such as Lambda Test, Tosca, Apple Tools, Percy. All of these tools really introduce visual AI, which make things for visual testing much more better. And you could test, for example, multiple browsers, multiple different versions of browsers. You could just one click in different viewports. And this was a very huge step in visual testing. Okay, so now we understand the evolution of the visual testing. Start pixel to pixel, then go into DOM comparison, and then we have the visual AI. Then we are in the starting last year, or even before the last year, we saw the rise of generative AI and large language models. And this was very important to understand, because large language models is now we could see we have like open source models, we have closed models like OpenAI and Gemini, and this large language model trained on millions of data and able to do a lot of tasks, right? So it's able to do a reasoning task, it's able to understand the natural language that that you give to these models. You are able to even fine-tune these models. You don't require any data. It's already pre-trained models, could do a lot of tasks. And even if this task is, even if this model is not trained on this task, it's still able to solve it, right? And this was a very important and opened a lot of doors, especially in quality engineering. And this, like, since last year, we have only textual large language model, right? Like, for example, the GPT 3.5 or ChatGPT, where you give only text and as an input, and the output is only as text, right? So, but now we have a new large language models, and this is called the multimodal. And this multimodal gives the opportunity that the inputs is not only texts, but it's also image. You could have audio, you could have anything as an input, and you could also get anything as an output. So you could get an output as an image, you could get an output as video, you could get output as text. So now we have a new opportunities, right? It's open a lot of opportunities for us to leverage these capabilities of this large language model in different ways, and especially in this visual capabilities. And this is something that I would like to focus in the next section, where we could see how these multi-models or multimodal could be used in enhancing the visual testing, and also in enhancing our quality engineering practices. So let me start with something very important. Is it really able to really understand the images? So if I give this image that we saw in the first slide, where I wanted to introduce the pixel to pixel comparison, is the models really able to understand this image, to understand the content of this image or no. So I just give the input as an image and give the prompt that describes this image in detail from color to material. So, and you could see the outputs of this text, of this input, that it's really able to get every details in this image, right? Start saying that this steering wheel, the color of this steering wheel is black with these yellow stitches, the material, it appears to be a leather, and also going into the dashboard, going into the central console. So it's really giving each and every details inside this screen. And even with a very small prompt, so I didn't write like didn't follow any prompting engineering framework or didn't do anything. I just give it a very simple prompt, and still it's able really to identify, understand objects inside this image. And this is something very important, because if you thought about it, you could really benefit and leverage these capabilities in visual testing, right? So why not to compare images using large language model? And instead of showing only difference, it's also understanding this difference, right? So let's see our first use case where we could do image comparison using multimodal. So in this simple demo, so I have here the login platform, here in the sign in, and here is the login. So there is a difference in these two, and it's very easy to visualize this difference, right? So you could see that this sign in and this is the login, and the color here is the sign in, and the color here is different. And if you did this with a visual AI, if you pass this with the visual AI one, it will work, and it will give you differences, like this is the sign in and this is the login and this is the color here different from here, but it's really doesn't understand, right? It really doesn't understand that this is a login form. It doesn't understand that this is a this difference is in the header. It doesn't understand what is this in general. So just giving you the visual differences, but without understanding. And this is the thing that large language model able to do. It's able to do reasoning, it's able to understand, and this gives you a lot of capabilities that you could leverage, right? So let's see, what if I give these two models to, I developed this small UI where you could just put two images and see if it's working. It's based on GPT-4o, and I just log in. Okay, this is the first image, and this is the second image. And I just wrote, okay, what is the visual differences between these two images, to see if it's really work, if it's really able. And you could see that, say, yeah, the header text in image 1 has sign in, but the image, but in image 2, it's logging in. And also the color of the button, it's purple, and the color of the button is red. So it's really able to identify, understand, without any inputs from my side, just to give it these two images, and it's still able to identify everything here, right? And it's even give you like some details also, that the overall layout, username, password, and forgot, and don't have any account, are consistent between the two images. So it's really important to see that, okay, it's really understand what's happening here, right? So with this multimodal, you could think, okay, we have already visual AI that able to identify difference, but we could enhance this visual AI using a multimodal to do other things. For example, you could extract data, right? So if you have a form, and this is an input image where I have this form, a registration form with a lot of data here. And if I just give this prompt, please extract all of this data in the image and put it in a JSON format. And what it will do, it will just go through all of these inputs in a visual way and extract all of the data here. As you can see, this is a student registration form, and this is a buggy tester, and this is a email and all of the things, and then just put it in this nice JSON format. And you could think about it, okay, if you are doing a UI test, how usually you will do it, you will go inside each and every form, right? And do a validation for the inputs here. This is something that you need to build. You need to build a page object model. You need to identify each and every element, and then you need to do assert for this each and every element. But maybe in the future, we could have something like this where you need just to extract the data, and this is your reference data. Next time, if I have any change here in this data, I could compare between these two JSON files. So it's something coming out of the box from the large language model that we could leverage this in data extraction and do assertion, for example. So this is the second use case. Let's take a look on the third use case. And this is something also important to do form validation. For example, I have these two inputs where I have the same registration form. And I asked here, what is the difference between these two forms? And what I wanted to show you also here is something important between that you could see how the models are evolving. Because in this use case, I used GPT 3.5 to compare the difference. But in the next one, I will show you when I used 4.0, how it's really enhanced. And you can see here, I have here a lot of differences, like this tester. Here it's capital, and here is a small, sorry. And this is, for example, male, female, and this date of birth is different, and this subject is different also. This music here is not selected. Here I have a file, and here I don't have, and this is like 4.4 and this 4.3. And just if you look at the output, so you will see that it's able to identify the difference, right? So it identified the date of birth, the subject, the picture, and the current address, but it's still missing some things. So for example, the tester, capital and small, it's not catched, and other things are also not catched. So it's are able to identify difference, but not all differences. And if I tried the same actually with GPT 4.0, which is the enhanced version of the model, so it's exactly the same two forms, and you could see it was able to catch all the differences. So before it was only 4 differences, and now we could see everything. And this is something very important because with evolution of models also, you could really have a lot of other opportunities. You could really improve our use cases, right? So this is something that we need to consider. Now we have GPT 4.0. Tomorrow we will have other models, and maybe in the future you have something much more powerful. And all of this could be really leveraged to enhance our quality engineering practices. And then let's go to the use case 4, where I used this multimodal to generate manual test cases from wireframe. So for example, this is something that we usually do if you are working in a project, you have a requirement, and then you have a design wireframe, and then you start writing manual test cases and then doing automation, right? But this is usually we spend a lot of time to write these manual test cases. But now with this multimodal and this visual capabilities, you really could do this in less than 1 minute, right? So just I said here, please generate a manual test case for the for this register wire framework and this login page, and you could see it's able to give me test case ID, it's able to give me preconditions, it's all test steps, expected result, post conditions. So it's really able to generate also manual test cases from this wireframe. So it's these visual capabilities of the multimodals could really help us in different ways. Then let's go to another use case where we could generate event effect reports. In the when we saw the visual testing, we can see, okay, the visual testing is able to identify the difference. So if I used the visual AI testing, it will able to see, okay, this difference here, and then we have a difference here. But as we said before, it's not able to understand. But with the generative AI, you have this understanding, and then you could even not only show the differences, but you could generate defect reports, and you could just post these defect reports. So you don't need even to do the analysis, right? So here in this case, for example, you could see this difference. And if I just use the same platform to see, okay, please generate defect report for these two login form. So as you can see, we have here the defect report. It's able to identify the differences. Let's see here, okay, this is the steps to reproduce. What is the expected result for image one? That the login should be displayed as a blue sign-in button. And also the top of the form should be like blue and gray circle icon. And this is the actual result. So it's able to generate you a defect report that you don't need to analyze the results, but you could just also have like a simple prompt that could help you to reduce the manual effort that we spent in analysis of the results, and could generate you a defect report. Then let's go into another evolution. So we saw that we start with large language models, and then we moved to the multimodal large language model. And now we have what's called the AI agents. And this is very important that we are using this AI agent now. And I think for the next year also, it's very important to understand, very important to learn. And this AI agents is something coming to be able to do also tasks, right? So large language model by itself is able to give you output, but it's not able to do tasks. And here, this is the benefit of agent. So if you have, for example, any query, you could ask, and then with a simple prompt template, for example, you could say, I would like to execute a test case, an automation test. And then this agent, you identify a prompt here to say to this agent, you are an automation tester. And the main idea of the agent, that the agent has these tools in hand, and it's able to identify the task. And based these identifications, it's able to choose which tools and act based on this. And this is a framework called React, Reasoning and Act, which means it does the reasoning for your query, understand what needs to be done, and then act based on this reasoning and choose which tools that could be used, and then go and format the output using the large language model, and then send you this response. And this is very important because you could imagine you could use this agent in a lot of things. You could do writing you code, executing you test cases, creating you an API test, executing an API test. All of the things could be done with agent. So I will show here one of the agents that called the Voyager agent. And this agent is developed to do actions on browsers. And the main idea here is that this agent have tools like click, go back, Google scroll, type wait. This is the tools that inside the agent, and that have access to Playwright AI API. So here I just wrote a small script using this agent. Just say, okay, please execute the following test case step by step. So search for keyboard. It will, first of all, access Amazon.com. It will search for keyboard. It will click on Amazon Basics. It will click on this item. And then it will write pass if the price equal $12.99. And you could imagine I didn't define anything. I didn't define any elements. I didn't create any bench object model. I didn't do anything. I just set up this agent on my laptop and just identify this instruction. And what will happen if I just play this? the main idea here is this instruction will go through the agent. The agent will realize I need to do these tasks, and it will try to do it step by step. And here, I just would like to stop here because here's the main idea of the visual capabilities. Because what will do this agent? It will identify each and every element here with an tag, with a number. So it will use the visual capabilities to see this keyboard or this image. It will take number 14, for example, or this search image, this search bar, it will take number 4. So you will see it right now. So you see these tags. It will be shown better in the next, but you could see here, and it will start to write here a search for keyboards. So I don't do anything. This is all the agents doing, and you could see here in the next page, it puts these tags everywhere, which means that it identifies elements with these tags using the visual capabilities, and then it will click, and then it will assess the price, and it will write pass at the end. So, and now it's finished, and you could see I didn't do anything. It just the agent's able to do this thing. So here, if you can see type 4 keyboard, and this means that the search bar has this 4. It's create an overlay over the web page, and this overlay contains the tags, and each tag, so this 4 is the search bar, and then it write keyword inside it. And this click 27 is exactly matching this Amazon basic law profile. So I think this is something very important, because I believe in the future we might see this agent in actions where you could do, for example, automation testing using the visual capabilities without needing any tools, right? So I think this was a demos that I wanted to show you to see together how Gen AI could be used in the quality engineering, especially the visual capabilities of the multimodal, and how this could be enhanced a lot of things, right? So what we have learned, we saw the evaluation of visual testing, how it started from pixel to pixel comparison, DOM comparison, and the AI visual testing. And then we saw how generative AI on visual testing, what is the evolution of the generative AI from large language model to multimodal large language model to AI agents. We saw different visual AI use cases from image comparison, data extraction, generating test cases, generating defect reports. And at the end, it's very important to understand this technology, try to embrace it, and try to use it with caution. And because also it's very important to have a responsible and explainable AI, right? So yeah, I think that's all from my side today. I hope you enjoyed it. I'll just stop sharing now and give the stage to you, just if you have any questions.
Yes, thank you so much for that informative session. We'll open the floors to questions now. And we do have a lot of questions in the box. I'll quickly put some of them in front of the screen. So we have this one from Arbor, who asks, how can we integrate this with legacy systems?
Yeah, I'm not sure if this is, yeah, I think this is very important question, right? So we all have our legacy systems, but you could see not to integrate everything, right? You need to choose really something that could work, and then start with it start small with it. So and this is usually what I do in our projects. We have a lot of quality engineering capabilities in the test analysis, in the test automation, in the test design, in the test strategy, and start to see where generative AI could be leveraged, and then start with a small thing and see if this could be improved. But I completely understand, because here also generative AI is based on the quality of the input. So if you have an input that is legacy, and it's not having all the information needed for the generative AI, you will not get the output that is needed. Well,
Yeah, I hope that helps. And heading on to the next one real quick, can visual AI handle testing the dynamic elements like video ads, picture ads, etc. in a web page?
so I didn't use it like in each and everyday tasks. As I mentioned, this is just to show the trends. But what I saw is that it was able to handle things like, for example, you have this pop up and you have this where you need to click, or you need to, for example, give codes to bypass the screen. All of this was working out of the box. So I believe it's really able to understand videos and to understand picture ads. So at least I used it also for video analysis, and it was working perfectly, and able to slice the videos into frames and then understand what is the content of these videos. So I believe, yes, it's able to handle all of this.
Got it. So we're already short on time here, but I'll just ask, this last question. Does this mean we can use visual regression for web-based front-end testing, appearance, color, etc., and dashboard testing?
I
I
think
believe this
so.
was answered properly in the session as well. But yes, of course, having
I
said
think
that,
so, yes.
yeah, let's take another one real quick. How do you ensure the accuracy and reliability of test cases generated by multimodal generative AI?
So this is very important, that each and every generative AI really, they encourage to have human in the loop, right? And it's very important. You just don't rely 100% on the outputs of this generative AI. You really need to go and assess the output by yourself, and even there's assessment framework, but at least it saves you the 50% that you do in the beginning, right? So it gives you something to start, but don't rely on 100%. Human in the loop is very important to do this reliability and accuracy check.
Yes, and with that, we will have to end this session as our time is up. For any questions that we weren't able to address over here, feel free to share them across Lambdas community. We will be able to take this up. Ahmed would be looking at those threads too and try to answer them with the best of his abilities. And having said that, we now have networking break in our fluid spaces. So by all means, you can head out. But before you do, I would like to thank everyone for joining into this session. Thank you, Ahmed, for taking time out of your busy schedule and walking us through the entire journey and the concept of how one could ace visual regression testing with multimodal generative AI.
Thank you.
Right. And
Thank you
this was
so much.
extremely insightful. Our audience was extremely entertained, and we could see that on the chat as well. And thank
Thank
you
you
so
so much.
much. Thank you so much, everyone.
Thank
See
you.
you in Fluid
Thank
Spaces.
you.
Take care.
Thank you. Thank you. Bye bye.